Before I get started, I want us to take a look at one of the homework problems from section 1.1 because it's a good transition into what we'll be doing today. Question 7 from section 1.1 presents the following picture, and it asks students why these toothpicks are not organized according to the base 10 system. Well, looking at this, we can see that the toothpicks actually represent the number, because we know that a number is something that can be counted or measured, and in this case the actual toothpicks is the measurement. So that's the number that we're looking at. That number is represented by the numeral name 167. And as we've seen in the previous session on operating in different bases, a number has the same numeral name. However, the symbolic numeral or symbol that represents the numeral can vary depending on how the number is grouped or the number system in which you're working in. So in this case, this question is asking us to think about the numeral that represents this number in base 10. And we know that base 10 has the following place values: units, tens, hundreds, thousands. And we saw in our last session that for units I can have anywhere from 0 to 9 units, but as soon as I get 10 groups of units, I have to regroup it into one group of 10. Each time I get 10 tens, I regroup it into one group of 100. Each time I get 10 hundreds, I regroup it into one group of 1,000. So in this case, we can only have 0 to 9 groups of each type of item. So in looking at the picture, it appears that there are a total of 17 units. Well, there's no way to represent 17 units because we only can represent 0 to 9 units. So what we can do is we can count off 10, because we know that as soon as we get 10 units that we can regroup it into one group of 10. So now looking at this, we actually have left over 7 units, which we can write that in because that's less than 9 units, that's less than 10 groups, and 7 is a digit that we can use to represent the units. Now looking at the tens, it appears that there are 3, 6, 9, 12, 15, 16 tens, which we know is impossible. So what we have to do is count our tens, and as soon as we're able to count out 10 groups of 10, we can regroup it into a group of 100. So if I was to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 tens can be rewritten as 100. And then I have 1, 2, 3, 4, 5, 6 tens. So the number 167 is written numerically in base 10 as 167. The original picture did not fit the numeral 167. However, if we wanted a picture of the number that matched our numeral system, it should look like this: one group of 100, 6 groups of 10, and 7 groups of 1. This takes me into the first slide before we officially begin our lesson, and I want to do a quick review of bringing it together from our session Saturday as well as the homework. Looking at the 167, that's actually a numeral in base 10 for the number 167, or the numeral name 167. So in this case, the 167 is the symbolic numeral. The 167 in words is the numeral name. And that numeral is made up of single digits. Digit 1, digit 6, digit 7. A total of 3 digits makes up the numeral 167. The number or the numeral 167 is in standard notation. Standard notation is a simple numeral with no decimal points or exponents. That numeral is represented by the number, as you can see the picture below, one group of 100 toothpicks, 6 group of 10 toothpicks, and 7 individual groups of loose toothpicks. So the number is the actual count or measurement that represents the idea. We also talked a little bit about expanded notation on Saturday. And expanded notation is actually showing place value by multiplying each digit. So in this case, I have a digit of 1, so that stands for one group of 100, plus 6 groups of 10, plus 7 groups of 1. So that would be the expanded notation. So up until this point, these are the key vocabulary words that have defined what we've been doing. So our objective for today is to explore the role that the digits that make up a numeral play in rounding and comparing numerals in the decimal system. Again, we have looked at different number systems and different bases. However, moving forward, we will focus on the base 10 decimal system. Okay, so let's take a look at rounding numbers. Okay, with 167, with rounding, the important part about rounding is that to round, you have to have fewer non-zero digits than what you've begun with. And in this case, we have the numeral 167, which is 3 non-zero digits. So that means in order to round this number, we would need 2 non-zero digits. So if we were looking at those 2 digits, 100 and 6 tens, that number would lie between 160 and 170. Now, the longer tick marks are 160 and 170 on the number line, which are tens. So in between 160 and 170 is 10. So if I was to divide that into 10 smaller parts, each part would be one whole. 167 falls there, which is a little to the right of 165. And it's actually 3 from 170 and 7 from 160, so it would round to 170. Let's look at rounding it to one with only one non-zero digit. So with only one non-zero digit, that means the other 2 digits would have zeros. So 167 will be between 100 and 200. Notice both 100 and 200 has only one non-zero digit and the other digits are zeros. So in trying to figure out whether 167 it's closer to 100 or 200, we actually break our number line up. So the longer tick marks now are hundreds. So that means the smaller tick marks would have to be tens. So we have 100, 110, 120, 130, 40, 150, 160, 170, 180, 190, and finally 200. Now our number is 167. So that means that it is between 100 and 170. As you are working through the class activities and the homework, you should have come across an idea of the zooming number line. The zooming number line works very well because it helps students to see the 10 pieces that are in between the numbers that they're looking at. So in this case, between 160, they're smaller numbers. And that's the unique part about our number system. You can always break a unit into 10 smaller pieces and 10 smaller pieces and 10 smaller pieces. So in this case, we are looking at the number 167. It's between 160 and 170. 160 and 170, those long tick marks are actually tens. So the smaller tick marks between 160 and 170 would have to be ones. So that's why we have the 161, 162, 163, and so forth. So 167 is approximately there, which is 2 past the midpoint. So that means that 167 is beyond the midpoint. So it's closer to 170. And we know that 170 is closer to 200 than it is to 100. Remember, the idea is if you make it to the midpoint, then you round up, you keep going, there's no need to go back. But if you haven't made it to the midpoint, then everything is closer to the lower number. Okay? Let's take a look at the number 3,367. I have a total of 4 non-zero digits. 3, 3, 6, and 7. There are 3 different distinct digits, but there's a total of 4 digits there, and none of them are zeros. So, to round, I would need to round to 3 non-zero digits. So in this case, the 336 would remain non-zeros, and then I would change the 7 to a 0. So that means that the number would be between 3,360, and 3,370. Notice with 3,360 and 3,370, each number or numeral has 3 non-zero digits. These tick marks are made up by tens, so the smaller tick marks that are within those two, that are between those two numbers, will be made up of ones. So that would be 3,361, 62, 63, 64, 65, 66, and so forth. Now our number is 3,367. So that actually lands at a point on the number line. So in trying to determine whether this number rounds to 3,360 or 3,370, the idea is to look to see which number is it nearest. Well, it's 3 from 3,370 and it's 7 from 3,360, which means that it's closer to 3,370. Looking at this number, let's see if we were to round to 2 non-zero digits. So that means we will be looking to see whether this number would round down to 3,300 or up to 3,400. So the long tick marks are actually hundreds. So the smaller tick marks would have to be tens. So it's going by 3,310, 3,320, and so forth. So our number is 3,367. So that means that it would need to be between 3,360 and 3,370. So I'm going to do my zooming number line to get a good estimate about where that number needs to be plotted on the number line. And on my zoomed out number line, where my longer tick marks are 3,360, 3,370, those long tick marks are tens. So the smaller tick marks between those two would have to be ones. 3,061. Of course, I didn't put it every numeral because I was running out of space. But each of those tick marks represent 3,361, 3,362, 3,363, and so forth. So in identifying the location for 3,367, it falls there, which you can see it falls to the right of the midpoint between 3,360 and 3,370. So if I return to the larger number line, I know that the number 3,367 is a little to the right of the midpoint, or right about there. So really, that number is closer to 3,370 than it is to 3,360. And in that case, 3,370 is closer to 3,400 than it is to 3,300. It's only 30 from 3,400 and it's 70 from 3,300. So that number would round to 3,400. Now, again, there's 4 non-zero digits, so we can look at rounding this numeral to one non-zero digit. So to have one non-zero digit means that the other 3 would have zeros. So that number would be between 3,000 and 4,000. So in this case, our long tick marks are thousands. So the 10 tick marks inside or between 3,000 and 4,000 would be hundreds. There's 10 hundreds that make up 1,000. So looking at the number 3,367 to see where it falls, we know that it will fall between 3,300 and 3,400. I'm going to zoom out to find out exactly where it falls. And in zooming out, my long tick marks are 3,300 and 3,400. So in between that 100 falls 10 tick marks, which would be tens. So 3,310, 3,320, 3,330, 3,340, and so forth. I'm going to actually have to zoom out a little more for this one because the number 3,367 falls between 3,360 and 3,370. So now my long tick marks for 3,360, 3,370 are tens. From 3,360 to 3,370, that's 10. So the smaller tick marks on the inside will be ones, which would be 3,361, 62, and so forth. So in locating 3,367, I see that it falls there. So it falls to the right of the halfway mark. So if I was to go to the previous number line, it will fall about there. And if I was to go to my initial number line, it will fall about there. So in looking at this, 3,367 is closer to 3,400 than it is to 3,300. And 3,400 is 400 from 3,000 and 600 from 4,000, which means it's closer to 3,000. So that numeral would round down to 3,000. What I want you all to do now is to pause the video and to work through class activity 1N that's located in the textbook by Sibylla Beckman. The class activities are in the back of the book, and class activity 1N is located on page CA-19. Hopefully you've had time to pause the video and you've worked through class activity 1. Now we're going to take a look at extending the decimal system and rounding decimals. Before we do that, I want to revisit base 10 materials because unfortunately we're not in class, but there are base 10 materials that we can use to model these numbers. So in this case, the numeral 321 in base 10 represents 321. In base 10 material, we identify which base material would be 1 unit. So if that's 1 unit, then that would be 10, because it would be 10 groups of that unit. So those are 10s. That's 100 because it's actually 10 groups of those 10 rods. And then the next one would be 1,000 because there's actually 10 of the flats for a cube, or 10 of the hundreds for 1,000. Now notice, with the base 10 material, you assign the value. The smaller cube is not always the unit. It depends on what you assign the unit to be. That's why in your standards throughout the text, and anytime you are working with base 10 material, you want to call it the unit, the rod, the flat, or the cube, because they can take on different values, as we'll see in the next example. So if this is my unit, my 10, my 100, and my 1,000, if I wanted to represent 321 with base 10 material, I would have 3 hundreds, which are the flats, or 3 flats, 2 tens, or 2 rods, and 1 unit for 321. Now, if the rod is my 1 unit, then that means 10 rods would be 10. And that means that 10 tens, or 10 of the flats, would be the cube, or 100. Notice I don't have a material that's bigger than the cube to represent the 1,000. However, my unit is a rod. What might the smaller cube be? Well, it's 1/10 of a unit. So using the materials in this way allows us to model decimal numbers. And in this case, notice the rod, the flat, the cube, and the smaller cube represents different values. Again, I can't emphasize how important it is. Do not assign and tell students the flat is always 100, or the rod is always 10, or the smaller cube is always 1, because that is not the case. It varies depending on what you identify to be the unit. So in this case, we would have 3 hundredths would look like that. It would be 3 cubes. 20 would be 2 flats instead of the 2 rods, as we saw in the previous problem. And then 1 unit would be a rod. So it looks very different. So with the base 10 material, is how the materials are in relation to one another. Notice how I'm using the number line to plot decimal numbers. I notice that 3 and 2100ths is between 3 wholes and 4 wholes. So my long tick marks on my number line are whole numbers. So between 3 and 4 is 1 unit. So if I was to break 1 unit into 10 parts, they would have to be tenths. So it would be 3 and 1/10, 3 and 2/10, 3 and 3/10, and so forth. So in this case, 3 and 2100ths, or 3 and 2/10 and 100, would be between 3 and 2/10 and 3 and 3/10. So if my long tick marks are tenths, between 3 and 2/10 and 3 and 3/10, that's 1/10. So if I break 1/10 into 10 parts, those parts will be hundredths. So the smaller parts would be 3 and 2100ths, 3 and 2200ths, 3 and 2400ths, 3 and 2500ths, and so forth. So 3 and 2100ths will fall about there. That's plotting decimals on a number line. I want you all now to pause the video and take a look at class activities 1F through G and 1L. 1F is located on page CA9 in the class activity section. That activity will actually practice using zooming number lines to plot decimals. Then I want you to take a look at class activity 1G. It's on class activity or CA page 11, and it also gives more practice with plotting decimals on number lines. And then last, I want you to take a look and work out class activity 1L, which allows you to see how breaking up the number line is used to find smaller and smaller decimals between decimals. And that's located on CA17. Hopefully you've had the chance to pause the video and work through each of those class activities, which we will review the answers and discuss questions that you may have during Saturday's upcoming class. So we've looked at rounding whole numbers, we've looked at plotting whole numbers, we've looked at plotting decimal numbers and representing decimal numbers. Now let's look at rounding decimal numbers. So let's take the number 3 and 2100ths. Currently, there's 3 non-zero digits. So if I wanted to round this, I could round it to 2 non-zero digits or 1 non-zero digit. So in this case, let's start off with 2 non-zero digits. So that means that 3 and 2100ths will be between 3 and 2/10 and 3 and 3/10. Again, the longer tick marks are tenths. So between 3 and 2/10 and 3 and 3/10 is 1/10. So if I was to break 1/10 into 10 smaller parts, it would have to be hundredths. So each one of those is 3 and 2/10 and 100th, or 3 and 2100ths, 3 and 2200ths, 3 and 2300ths, 3 and 2400ths, and so forth. So 3 and 2100ths will fall there, which means that 3 and 2100ths is 100th from 3 and 2/10, and 900ths from 3 and 3/10. Therefore, it's closer to 3 and 2/10. Let's take a look at the same example if we wanted to round it to one non-zero digit. So 3 and 2100ths would be between 3 and 4. So our long tick marks would be whole numbers. So from 3 to 4 is 1 whole. So if we were to break 1 whole into 10 parts, each part would be tenths. So 3 and 2100ths is between 3 and 2/10 and 3 and 3/10. So we use our zooming number line to identify where exactly it's located. So now my long tick marks on the zoomed in number line is 3 and 2/10, 3 and 3/10, which are tenths. So between those two numbers is 1/10. So if I were to break 1/10 into 10 smaller parts, they would be hundredths. Now I can locate 3 and 2100ths. Notice it's closer to 3 and 2/10 on the left side of the half mark. So it's approximately located there. So if I'm looking at that, that is actually closest to 3 2/10 than it is to 3 3/10. And 3 2/10 is 2/10 from 3 and 8/10 from 4. So it's closer to 3. That numeral would round down to 3. Now I want you all to practice rounding decimal numbers. Please take a look at class activities 1, O, and P. They're located on class activity pages CA20 through CA21. Hopefully you've had an opportunity to work out those activities. The next thing I want you all to do in your spare time is to summarize what we've done. Think about how rounding digits, numerals, can be used to compare numbers in section 1.3 of the text. If there aren't any questions, please complete all activities, upload them in the assignment Dropbox by this Friday, 11:59 p.m. And please be prepared with questions that you would like answered during Saturday's class.